I'm a PhD student working in the data lab. Today I'll be talking about the LLMs as a judge. That is how LLM can be used as an evaluator of the LLM generated outputs. So at first, suppose you are an owner of a big show company. So you sell shows and you want your users to give some feedbacks or based on different kind of questions. You don't want to interact with them for all the questions in person. So you generated a chatbot that gives response to the users based on different questions and how it is trained. So there are some users, they ask questions, and the LLM based chatbot provides the response. So here are some sample questions and sample responses, like what materials are used in your eco-friendly shows, and can I get replacement, or how do I track my order. So now the question is that how the owner would judge that how our model is assisting the users. So in that case we need human, maybe we think about the human evaluation, but this is very scalable and difficult task. That's why we are thinking about using an LLM to evaluate the outputs, this interaction, dialogue interaction. So how can we do this? For this we need a prompt, and we will give the questions and we will give the responses of the responses of the LLM that was given for the questions of the users, and then we ask the LLM to check whether the responses of the chatbot was helpful or not helpful. So this is the judge LLM, and based on the evaluated inputs on the left side, it generates different kind of responses, whether it's helpful or not helpful. So this is the basic idea of LLM as judges. That's how it generates the evaluation. So what is an LLM as a judge, if we want to know? So the first of all, it's using LLM to evaluate the AI generated text based on certain criteria in an evaluation prompt. So but important thing is that it's not a single metric, just like accuracy and some other techniques we used in machine learning models. Rather we can think of it as a flexible technique that tries to be like the human judgment. So why we can have we use it, because it can evaluate outputs for quality, relevance, accuracy, and different kind of metrics, and it can be applied in different tasks like summarization, dialogue, coding, and more. And the benefit of it is like it's scalable. It can it can evaluate a large number of data sets, and it's consistent like human legs consistent, because they have fatigue when they have to annotate a large number of data, and it can do these things in an interpretable way, and obviously it can help human evaluation, less dependence on human evaluation. So for this research talk, I will focus on these main points. At first I will say that why the LLM as a judge is used, or how it functions, and how it works, and in which sectors it is being used, and how we can judge the LLM judge itself, and what are the limitations that are associated in this process. So this is the basic overview of the LLM judge system. So I will discuss in details each part, but first if we can think of this from three points of view. First one is that input, like prompt input, what we give in the prompt, and then we can think about the system, how many system or LLM is involved in the evaluation process, and we can think about the output, how we are generating the evaluated output. So the input, according to the input, we can have three criteria. One is like evaluation type, another one is evaluation criteria, and another one is evaluation reference. So let's first talk about the evaluation input types. There are actually, I mean, um, in a broader review, there are three kind of evaluation types. One is point wise. The first one is point wise evaluation. It's very straightforward. So it's like evaluate, it can be categorical or it can be continuous. By categorical we mean that we ask the in the prompt that judge this article, for example article, whether it is supported by this context or yes or no, something like this. It is categorical output. Or in continuous it can be in a Likert scale, or we can think about the score this output from 1 to 100. So there could be continuous evaluation, discrete evaluation, and categorical evaluations. But the point is that we will have one input and we have one discrete output. So and then comes the pairwise evaluation. In case of pairwise evaluation, we will have two responses from the LLM. So we will judge by the LLM which one is better than the other. And for example, we can recently, I mean, I think in GPT-4 when we use it, we can see that they generate two kind of response, and they said that which one is better, rate the one which one you like this thing. And then comes the list-wise evaluation. In list-wise evaluation, the evaluator is given multiple types of responses from the responses from the main LLM which we are evaluating. So and then the judge LLM evaluates which one is better. It gives that this one is better or this one is worse or something like this. Then comes the criteria, that in which criteria we can judge the LLM. So it can be and usually we think of a different kind of quality. The text quality, we judge different text quality, like linguistic quality, like grammatical, syntactical, like content accuracy, how much factually it is correct or not. The text is also task specific metrics, like in different depending on the different domain, we may look for different kind of quality of the text. Also from the perspective of user experience, whether it is helpful or is not helpful, or whether how is the sentiment, whether it is positive, whether it is negative. But the point is that the right criteria depends on the application context and how you prompt, and also the requirement of the stakeholders. Then comes the reference based or reference free evaluation input. So reference based can come like as you can reference based means when you will evaluate with the response, you will give a context context with the reference in the prompt, in the evaluation LLM judge prompt. You will give a context that based on this context judge this response. So it can come just like an answer and also a reference answer, just and it will give verdict like yes or no. Or it can be answer and a question, another question that for example, does the response fully answer the request? So you should have a context, and then the criteria will be given, and based on this it will verdict whether it is yes or no. And another one is like, it's most likely like RAG approach. You already know something about RAG approach. So in that case, you have answer, you have some retrieve context from vector database or these databases, and then you will have questions at the questions with this retrieve context, and then you will ask the LLM judge to evaluate the result, evaluate the performance. So the one of the key thing is that among all these of criteria or input types and the references, that it's not like you can have in a prompt you can have reference, you can have criteria, different criteria, and you can have different kind of input types. So this is not that only one way, it can be multiple way. So in also in reference free evaluation, it's just the opposite. There will be no reference, and you will just have a response, and based on the judge LLM's internal quality, intrinsic quality, and alignment with the source context, it will judge whether it is good or it is bad. So it's totally dependent on the judge LLM itself. So based on the how many evaluation system is related in the judgment, the first one is like single LLM system. We can see that there is an there are some inputs and there is an only one LLM. It might be used for all of these criteria, option, and this, and even you can ask for reasoning and there will be the response. So it's very simple and scalable, but obviously there are many issues. It might be biased, because if you judge the same thing, the output response with the same LLM, it might create different biases. And another one that is being very popular is like multi-LLM system. So in multi-LLM system, you will have different kind of LLM. We can think of agents, or maybe agents, or we can think of different LLM evaluations, not necessarily agents. But the point here, challenge here is the main consideration should be collaboration, competition, and collaboration means that how you will collaborate the outputs of different LLM judges outputs, how you will collaborate their outputs to come to a final evaluation output. Also the competition means sometimes if you judge one agents or one LLM's outputs with other LLM outputs, that may sometimes give you a proper idea about what is happening. And another one that is not here is like synchronization of the outputs. Apart from collaboration, like how from one LLM the input is the output is going to another LLM judge, and how whether it is like sequential or something like this. So there are also some issues like resource intensive, it costs a lot. Obviously. Resolving how you will resolve the conflicting judgments.
So are they trying to communicate the responses between themselves, or trying
Yeah,
to
it could be multiple ways. So these are the issues, that whether how would you communicate between judges, whether the response you judge by one LLM, whether you want to send it to another LLM, or you want to do it like separately, then come to a conclusion. So this kind of thing you have to think about depending on the task. The third one is the including human in the process. So one of the critique of only using LLM as a evaluator is like that the main purpose of LLM evaluation is that aligning its evaluation just like human being. So if there is no human human involvement in the process, so it might have some different kind of biases. So it might how would we trust the result. So that's why most of the cases they propose to use the human intervention in the process, and so this is good in this kind that it can provide you more robust answer, or more understandable, or more consensus answer. But there are high cost, like when you include the human, obviously you have cost, scalability, and other issues that are related to human that comes in into the scenario. So now we will talk about the evaluation based on the output, how LLM generates the outputs. So the first one could be evaluation results, just just giving a result after the evaluation, that this is the response from the previous AI generated text, and then just give a score or give the ranking of the result, or select like multi-class, or if you want to say that which one is the correct one, something like this. This is based only on the result. Another one is that you can give the evaluation output as a along with the result. Maybe you want the explanation as well, so you want the reasoning, you want the justification, or sometimes you may want the decision, that what will I do based on this. So the LLM can give attach this kind of information in their generated judge output. um, Another one is the feedback. Yeah, LLM can add feedback. I think even today when I was checking, I saw that LLM is generating feedback. Like if you say that given a text, can you generate the summary, and then he will generate the summary, and then he not I'm sorry, it will it will ask whether the generated answer, do you like it, or do you want to refine it, something like this thing. That means it will add feedback itself, or and then based on this there might be different kind of improvement that you want. So now we will look into the different kind of function that LLM judge LLM as a judge can do. uh, like performance evaluation, it can work for performance evaluation, it can work for model enhancement also, like data construction. So at first I will look into the performance evaluation part. So something might look like the similar that we already saw it, so by performance evaluation we understand that response evaluation or model evaluation. So in case of response evaluation, we only assess the quality of the generated text response of the LLM which we are judging. So it only assess that quality of the response, and not the model itself. So we can think that this is the response, just what is the accuracy based on the criteria, what is the relevance of the text with the context or something like this. And in case of model evaluation, the purpose is to judge the model itself. So we can have different kind of tasks like coding, like comprehension, text comprehension, and like summarization, different kind of tasks. We will give it to a particular LLM, then we will check that how it is performing on different kind of tasks, and based on this we will rank this, or we will give some scores to this, that it performs like this for this specific task, for this specific task it works overall, it works like this. And I think in case of like paper publication, we do this kind of uh, uh, evaluation when we use multiple LLMs for our experiments. We provide those information that for accuracy, for relevancy, for different kind of input criteria, uh, we have these scores for these models. And then comes the model enhancement. LLM can be used for LLM judge can be used for in enhancing the model's performance, and uh, one of the thing this is kind of advanced way, because in the trade the traditional, I would not say traditional, I mean commonly used ways, like we saw before, those might not be always, there might be many issues. So there are some, we want to enhance the model output, that how we can increase the performance of the LLM judge. So first one could be like reward modeling, and then it can work as an verifier. Another way is that we can we can have feedback loop or refinement of the judgment, and then again judge the model. So in case of reward modeling, we can use reinforcement learning. So for example, RELC CGPO. So in case of RELC, it is traditionally we know about RLHF, that is reinforcement learning with human feedback. So in RLH or reinforcement learning, issue with reinforcement learning is that it uses sparse reward modeling, but in RELC it uses the dense reward modeling. That means that in case of traditional reinforcement learning, to come to a optimization, to make the reward model optimized, it goes randomly and come to that position. But in case of this, it looks for each step, so and evaluate that output, and then come to an optimized reward model. In case of CGPO, how it works, it for different kind of tasks, for example coding, summarization, and there might be some other task, answered question answering. So those similar kind of tasks are grouped together, and then we will assign different model for each kind of task, and then we generate some grouped results. So it helps to reduce the biases, that one bias is not affecting the other task. So these are some approach with reward modeling. Another way could be acting as verifier. So it verifies outputs during the training inference, the selecting the best result. One of the ways, best of n sampling. So best of n sampling is that it is based on the response itself. So you will not I think, yeah, it is based on the response of the model that we are judging with the judge model. So given a model, it has, we will generate multiple response of that model, and then we will ask the judge model that which one is best among these things. So this is based of n sampling. And then another one is self consistency. Self consistency is like, given a model, it can generate multiple judgment for the same kind of for same kind of evaluation. So we might have different kind of criteria, and we will see that whether this judge LLM is consistent in its final evaluation result. So based on this, we can check that how the result is good or not. And tree of thoughts and graph of thoughts, yeah.
So if the LLM can work as a judge or a fire, means it's able to tell the good from bad. Why not directly using the LLM? Why using that only as a judge to train the model?
Can you specify?
Why don't you directly use the LLM
For what?
for the task that you want to train your model for?
The original LLM, or the why we are using another LLM? What is the why we are using another LLM?
Yeah.
Okay, so if we use the same LLM, then what will happen, that there will be a different bias. And one of the bias is that if you judge an output that is generated, suppose we are using GPT-4, we generated our output with this, and we are judging this output with the same model, then what happens is that it is always prone to giving the more confidence to its own output. So and there will be, when you use the same model, same training data and everything, so it will be always somehow influenced by the model itself. So how do we know that it works different with other models? So our model, current model, might have some issues, might have some performance might vary depending on the task, how the model is evaluated. That's why we use, sometimes it is useful to use the same LLM, sometimes it is useful to use this different LLM.
If you use a different model and you use the feedback from that model to enforce the training, then the bias from that model will be finally enforced into the
actually,
model being trained.
no, I think there are actually different kind of techniques. It's just not that it directly goes. And what you said, that if it is like we directly give the feedback, one of the approaches like adding the feedback itself. Yeah, it is one of the critique that there could be biases. Though it shows some kind of improvement, but in some cases it didn't show improvement, and there could be bias. And yeah, depending on the task, you have to decide that whether we want to minimize the task in this thing or how it is performing. Okay, so acting as verifier. So one of the was best of n sample, another one self consistency. Tree of thoughts and graph of thoughts. I think we already know about this thing from the first presentation. We will have different reasoning paths. We will, I mean, not we will. LLM will have different reasoning paths. LLM judge, and it will find the optimized reasoning way. So obviously there are many issues: cost, time, resource constraint, many issues. And the feedback refinement, it provides like actionable feedback or iteratively improves the outputs. So self refine and self debugging, there are two ways. So in self refine, it defines the generated output based on the reference, maybe based on the human. There might be human, there might not be human, depending on the how the a system is designed. And self debugging, it is like correcting or self correcting the code. So if you generated a code for a specific task, that you ask the LLM that generate the code, and in self debugging you will ask that check the errors for each step. So based on the errors in each steps, that then finally you will find that how much error was done in the whole code, generated code by the LLM. Um, then comes the in case of data construction, it has been very useful, maybe not always. So in case of data construction, we can use LLM for data annotation purposes, also for synthetic data generation. So in case of data construction, data annotation, we want to replace a human being with LLM to annotate or to label the unlabeled data. So obviously there are some issues if we don't involve the human, and since the purpose is to align the judgment with the human, so one of the recommendation in explain then annotate, in that case they ask that the judgment before labeling the LLM, before labeling any task on certain criteria, you will ask the LLM judge to explain why you are annotating this. It might help to for the annotation and for the verification.
Yeah, so for data annotation, instead of just asking this is the row, can you please predict it? Can we use
Can you
something like
please what?
multiple concepts combined, like for the example tree of thoughts or graph of thoughts, or maybe you used three models and it gave you three predictions, and you use another LLM as a judge to say which one is correct, like the verifier model.
Yeah, I think it is possible. It's just the saying that what can it can do as a function, but you have to think about when you are thinking about tree of thoughts or graph of thoughts, that whether you have that resource, you know, yeah, all the issues that is related to it. But I think it's possible. But um, one of the if you, I mean, I saw this critically multiple times that if you don't use human in any way, um, it obviously might have. But the point is that we don't have the trust that it is actually doing good.
I mean, are there any studies that show which combination of works are better? Like, for example, chain of thoughts with as a verifier for multiple ones, or maybe another concept combinedly yields better results.
So far, I didn't check in detail whether there is something like this, but there are some models like, I mean, some papers that talk about that. For example, instead of prompting like instead of prompting like scoring based, if you give the categorical judgment, then it is better. Some this kind of thing, but maybe it can be if it is not existing, maybe some day you can do it. Okay, so uh, so in explain the narrative, so we will explain the level reasoning before it, and for active learning, it for active learning in annotation, it focuses on the um, uh, focuses on the most important levels. I mean it is a kind of refining method, a way, so that the level that are not good, that can be discarded. So I didn't go through the in details, but there are papers on this in details. And data synthesis, it generates the synthetic data sets. Obviously, synthetic data set is useful for many cases if we don't have the data, and if we and it helps to broader generalization. Even if we have some data and we want to generate more data, then this LLM as a judge can be helpful. There are ways like self-instruct, star, REST STEAM. Self-instruct, it generates synthetic data on instruction level, like it what is this, it works in the instruction level, and in the star and RESTM it works on the reasoning steps to generate the synthetic data.
So back to my previous question, if you have a model and can do the data annotation, then why you want to use that to annotate the data and do the training again? Why just use that model for annotation, for classification like that?
Why we if we have
Why not directly use that model, use the judge to work if it can do the work?
So for the data annotation, the point is that okay, the point, there is a difference between judge and I think you can use the model itself for judge. I mean, there are many ways. So for example, if I have a model and I am annotating some task. For example, I work with the policy document, so I want to find the intent. So I want the model to find the intent of this text, different kind of text. What is the intent of the policy intent? What is the policy intent of these things? So the point here is that if we can judge with we are annotating this, but now how do we know that the annotation is good or bad? You got my point. So you can use the same model. It didn't say that we have to use the different model. You can use the same model, or you can have multiple models. One of the ways that you can use multiple models, even in the same model, and then check that whether they have the similar kind of consensus like the human annotators. When you have multiple human annotators, we check that whether they have the similar alignment, whether there is any conflict. Then we solve these kind of issues. Similar way, we can annotate with the same model, or we can use multiple models. So that is
I think it's kind of related to the agent topic that I mentioned. One agent technology is called Auto GPT, and the underlying mechanism, the underlying large language model it is using is the GPT-4, and the way that it works is that it works autonomously, which means it runs iteratively. So initially it gives a answer, and it asks the same model if it's the good model, if it's the perfect answer or not, and it runs it iteratively until it gives you a better and better result. So yes, the model is able to give you, I mean, finally it is able to give you a very good answer, but it may not be the first answer it gives you. So I think,
Yeah.
it's the same purpose here. Sometimes it has the ability, but you want to have a judge to keep giving prompts and improve the result.
You want to train your whole model to be smaller and faster?
No, perhaps after using judges, the model is able to give you a better answer for the first answer.
I mean, it's like as what you said. I think there are some issues as well. The self-refinement bias. So LLM is always, if you use the same model, what happens that, for example, suppose at first I gave an task and I told the LLM that polish this task, and then it will give an answer. Then I said that I didn't give any response that it is good or bad. Again, if I say that polish it again, then it will give another one, and then finally, suppose again I want another polished version, then it will give again another. But if then we ask that rate the answers, then what happens that it always in cases they found that most of the cases it gives the best score to the last one, because they think that since I'm asking for multiple revision, maybe I was not satisfied with the previous one, so they give the last one the best score, but it might not be the best score, best response. So that's why you need some it is better if you use the different LLM. Yeah, and also if you have human in the loop to verify. So now that what are the key considerations for adopting the LLM as a judge? So the first question is that what baseline we are comparing an LLM evaluator against, that what should be the baseline if we want to evaluate, and how will we score responses via LLM evaluators. And third one is that what metrics will we use to evaluate LLM evaluator. So we have to, if we want to use the particular prompt, particular criteria, particular input or the system, we have to think about all of these points, and based on this we will consider that which one we will use. So meta evaluation of LLM, meta evaluation is that evaluating the judgment of LLM itself. We might it might not do better. We don't know that just using another LLM or using the same LLM, we don't know that how it is good or bad. So in that case, the gold standard is the human judgment, because the main purpose, I have told it multiple times, that to aligning the judgment of the LLM with the human. And primarily 3 ways. There are actually many ways, many more ways. So I just put these 3 basic ways. The first one is like using touch specific benchmarks, like human eval, Frank, MLL as a judge. Human eval is for like code of evaluating the function of the code, function of the code. Frank is like fact checking how it is benchmark, how it is good or bad. LLM as a judge, I think it is for what is this, summarization kind of thing. I might be wrong. And baseline model, it is fine-tuned class. We can use fine-tuned classifier or reward model, but this is not kind of recommended, because it if we want to judge the LLM judgment based on another fine-tuned classifier or reward model, it might be too complex. Because reward model itself is complex, fine-tuned classifier, it might not be that true. So it is generally not recommended, but sometimes may be useful. Another one is that metrics. There might be classification metrics. There will might be correlation metrics, like classification metrics like accuracy, Pearson. That means that how much the judgment by the LLM is aligning with the human judgment. The other metrics also work on this main theme, that how the judgment is similar to the human judgment. There are Cohen-Kappa's inter correlation coefficient agreement measures, different kind of measures. And if we think about the application, there are different kind of application of LLM as a judge. We can use it in medical sectors for different kind of reasoning why this happened, for education, for math scoring, assignment grading, for legal cases. It is being very popular in legal cases, that giving the judgment or verdict of different scenarios. And information retrieval, just like for the researchers, that ranking, and different. We actually, researchers are focusing many areas in information retrieval, says like RAG and others. So multimodal is another interesting field to talk about the LLM judges. So now I will talk about, in short, the limitation and future work that are related to the LLM as a judge. There are many limitations. Primarily, we will talk about bias, adversarial attacks, and then some inherent problem with the LLM judge itself, model itself. So the first one that is really interesting, it is like position biased. I didn't know it before I did this actually. So it is like, for example, you have a with response, which you have a prompt for in the LLM judge, that which response is better. You have 2 sample response. from another or the same model. So response 1 and response 2. The first time you put the response 1 in the first position, response 2 in the second position. Again you use GPT-4 to evaluate the same thing, but you put the response 2 in the first position, response 1 in the second position. So we see that how the result is different, the verdict is different. First case it said response 1, second case it response 2. So in both cases it is giving the verdict for the first position. And for the second case also it is for the continuous not like what is this, numerical values like 1 to 10. In this case also they are giving different values based on the position change for the same response. So this is called position bias, that how you are presenting the response in the prompt. Based on this there might be bias. Also there might be verbosity bias that if you have it's found that if you have lengthy documents, it is giving more better score to these lengthy documents rather than small documents. There might be content related bias like sentiment bias.
Yeah, I mean, this is out of maybe this question, but do you know how to mitigate the positional bias?
Yeah, I saw the way is that you have to multi-turn. You have to check the um, judge it in multi-turn. So and in each case you will change the position, and it might be random sometimes.
Like self-consistency.
Yeah. And sentiment bias is that usually LLM is most of the LLM is trained such that when you have to judge something, they don't give any controversial. Usually, it doesn't give any controversial answers. It is more prone to giving positive, neutral tones to the answers. And token bias, that what is more frequent in relevant tokens in the training data, it always favors this. When giving judgment, it favors this. Also context bias, so based on the cultural contextual examples, it can give different kind of verdict for the same scenario. Some social related bias like authority bias. There was an example that if you have a response where you put the citation, it might be fake. They don't know that it might be fake, like this is cited by the here. If you give the citation, it will give more score if you don't give the citation, even if that citation is wrong. So that is called kind of authority bias. And bandwagon effect, it is if you have a response and you gave here that the majority you are asking to, suppose you have two response and a response B, and you also gave a text that most of the people think that response 1 is better, kind of thing, something. So if you add anything like this, it will give the verdict to the majority, since it already mentioned something like this, majority votes. And compassion fed bias, usually compassion fed means that when a crime or is done to the bigger population, it doesn't feel that much compassionate. We don't feel compassion to them, but it is it happens for one single person, maybe we feel more compassion. So these kind of issues might arise in LLM judgments. Also diversity issue based on gender, ethnicity, it might give different kind of tone, different kind of judgments. Also cognitive related biases. One is self-enhancement bias. We already talked about this, that it is if it is it outputs favors the same model outputs. Refinement bias, if I talked about this as well, that if which one is the final defined version, it always guarding that is the best one. Overconfidence, it gives it shows overconfidence giving the judgment, but when you ask more and more, it shows that, oh, I don't know, something like this, but I'm not confident. As this kind of bias may arise. Also distraction bias, when you add some irrelevant details, might be it can increase the score sometimes. Fallacy oversight bias, it's like it, though it is giving some verdict, but it might not be based on the actual fact. So this is fallacy oversight bias. Another one, now we will talk about the adversarial attacks that might happen in the LLM judge itself. So it can affect, if there is an attack in the LLM judge itself, it can affect the judgment. So here the example, you can see that they just used in the scored the summary between 1 to 5, and there is a line, this is a context, and in first case it gave the 2.3 score, but in the second case you just added a single phrase, something like summable, that is not relevant to this, and this thing increased the score like more than twice the original score. And similarly here we can seeing that it is giving different verdict just because we added some random thing. So it also gives the irrelevant content for longer context. It favors that longer context things. It might be also true here. So this is universal attack phrase, like short crafted phrase in inflate LLM scores, and it can transfer across different models judgments. Also we have benchmark manipulation optimization based attacks, cross model vulnerability, different kind of adversarial attacks that are prevalent, that can also affect for benchmark, like it can, if it can deceive the automatic evaluation system to produce artificially high scores, like uh, uh, based on the different benchmark might have different kind of prone to different kind of attacks. So based on this, if that LLM judge that you are using is prone to those kind of uh, if that is using that kind of benchmark, it can affect the result. And also of different kind of optimization technique can be used to deceive the model itself. Also cross model vulnerability, so if using smaller a vulnerable smaller model can manipulate the result of another model output. So these are mostly people who work on this, they might know better. I don't have that much experience on this thing. So this is the basic overview. mm. And some inherent weaknesses of LLM, like knowledge recency, hallucination, domain-specific knowledge gap, and for all of these things, we can have different solutions. For example, knowledge recency, we can use RAG, periodic fine-tuning, continual learning frameworks. For hallucination, we can use the RAG itself also, and we can cross-verify the outputs. For the output of the we will have different kind of outputs, and we will see that whether the different judgments are same or different. Based on this, we can say that this model, the judgment is hallucinated or not. Domain specific knowledge, we can use domain adaptation. Based on the specific task, we can use domain specific information, or we can use RAG to mitigate this problem. There might be some other mitigation ways, like addressing bias, fairness, since these are the some crucial issues that are related to the LLM judgment. So we can regularly audit for bias, fairness in outputs. Also enhancing the domain expertise, maybe we can use the domain stakeholders who can properly know that whether it is right or wrong, or human editors and different approaches. Also we can use reducing the prompt sensitivity, managing the computational cost. This is also important when we judge the LLM's judgment. I'm not going in details on these things, so it needs more reading on the papers. And so this is the final slides, and key takeaways of this presentation is that LLM as evaluators are versatile. So there might be many ways, and to evaluate the response, and obviously it depends on their task, depend on many issues. Also the evaluation is context specific. Based on the context, it might differ, and many challenges exist. The most of the exist is like bias, scalability, prompt variability, how it affects the LLM, and there have been many works on this. And also human AI collaboration matters. As I said before, mostly it is recommended to add human if you have that access to at the human collaboration in the process. Also, think beyond the paper. Practical use cases might affect the issues, and there might be many avenues to explore in future. So some of the references I usually mainly followed the first one. It is very helpful. I think the second one is also the recent, but it's kind of similar, and some online resources. So yeah, that is all of my presentation. So do you have any question?
I have one question.
Yes.
So my question is, so to judge the LLM as a judge, like using LLM as a judge to get a score, and I want to judge how LLM is judged as good other than human. What other approaches can be applied?
Instead of using human and instead of using LLM,
I don't want to use any human. That one approach you mentioned that we can compare the result from human and judge LLM. Suppose we don't have any domain expert or we don't have any human. So what other approaches I can apply to judge my LLM?
so the main question is that if we don't have human, right?
Yeah.
So I think we already see some approach like using. There is one way, it is reinforcement learning using AI feedback. So this is one of the purpose that what you are saying. If we don't have human feedback, then what we can do? So they use the another AI, another LLM models, multiple LLM models or reward models, and then they have many internal ways to judge the things, but the main purpose is to use different AI feedback instead of human feedback.
Yeah, but the main goal for feedback is improve the LLM performance.
Yeah.
But my question is, I have a ChatGPT, and ChatGPT
Main
generates some.
purpose improving LLM performance.
I think so because we are providing feedback to improve the result. But
Yeah.
I have a model, and this model says the score is 5, but I don't have human evaluator. So how do you ensure that 5 is good?
That is a good question. I think whether still, if you are a user, I think you are there is obviously some context. So the point is that if you don't even have a human evaluator, you might have some context. You should have some context. You should have some ways that will say that this is good or bad. So another, I don't know that whether there is any approach. If you know, you can share with me. But
I think multiple LLM can be applied.
yeah, that is already there, that multiple LLM, and seeing that but again what you said, that how do we know that
Yeah, it's
this is
little
good or
bit
this is
tricky,
bad?
yeah.
There still you need some kind of human intervention.
You mentioned there are a lot of challenges using LLM as judge. Do you think it's helpful right now to use LLM as a judge in cases like medical, because there's no room for error in that situation?
Yeah, I think first of all, task specific. So depending on the task, you have to think that how much it useful. Also, the how much improvement has been done with the LLM judgments. So, for example, in recently there are many papers. They evaluated the different models, that how it is performing on different tasks, and GPT-4 is doing kind of more than 95% like human judgment. But obviously every paper is not considering all the use case scenarios. So depending on the scenario, before you using it, you have to actually have some ground truth, or you have some more knowledge that it is useful or not, and it's your decision. You have to decide that whether it is useful or not.
Do you think in the future we'll solely rely on LLM as judges?
I think so. I'm hopeful. I'm from computer science, so I think
Do you think like human wouldn't be there?
the point is that here comes the ethical issues as well. So whether the people who make the the guidelines, whether they want this to happen. So there are obviously some people who want this to happen, and some people want that there might be some guidelines that how much human intervention should be there. So it depends on these issues as well. That yeah.
So the LLMs can be judges for another LLM, is it possible that you can use the third LLM to evaluate the previous LLMs as judges, or is it possible you have the fourth one to evaluate the judges of the LLMs? Do there exist those?
Search.
So the first LLM is the LLM for generating answers. The second LLM is the judge to evaluate the first one. The third one is to evaluate the second one,
yeah.
and the fourth one is to evaluate the third one.
Yeah, if you have that money cost and everything, I think you can, but it depends. That you can do it. They never.
No, I'm asking, are there any existing work for this kind of?
I think judging multiple judges, I think I didn't see that many judgments. There might be different judges. I saw different judges, like same response. It is judged by multiple LLMs, but the one that you said, the one step, like meta evaluation of the first judge, I don't know whether there is any existing work that is again judging the second judge, and I don't know how long it will go on and on. So yeah, I don't have any concrete answer because I didn't notice any paper.
Okay, so to mitigate the positional bias, you said that we can go for multi-target approach. So what will we do? Like we will get multiple scores. So we will compare it with the ground truth, or what's next?
Okay, so the point here is that position can include bias. I mean, position can. Okay, so in multi-turn approach, what I said is that you can have multiple answers, and in each multiple judgment. In each judgment, you will have randomly you can give the positions, or you might have you can yourself do the position checking, that first one, this one, second one, this. So this is different issue than the second issue is that you said that how we will judge. The point is that this approach will mitigate the bias. It is proved by some research, but for the judgment whether it is doing good or not, we need the approaches that is used for the judgment. We might need some human evaluation, we might need multiple model and this kind of thing.
So like after multiple turns, when I get multiple numbers, so human will decide which one is right.
Yeah, at first for the evaluation you have to decide. You have ground truth, So based on this you can refine, you can decide which one is
we can
better.
do majority voting.
Yeah, majority voting as well. But if we have ground truth, we don't need majority voting.
And for the functionality of LLMs, there was an approach, model evaluation. So what's the input you are feeding to LLM for model evaluation?
So by model evaluation, it means that you want to judge the model's performance, different LLM models performance. So for the input, you can check if you think about the input for the LLM judge. Are you talking about this? Yeah. So in LLM judge, it depending on the task specific. I said that you can judge the model based on different tasks, right? So if you are judging the model for text summarization, you can have the input prompt based on this text summarization. You will check for this. If you have different coding or other, you will have the prompt. That will be organized like this. Any other questions?
I know most of the LLMs used as judges are trained on the file or huge data set. Did you find any LLM which is fine-tuned and which is acting as a judge?
Fine-tuned LLM acting as a judge. Did I find something?
Did you
Okay,
cross any research?
I think there are fine-tuned LLM. What I said that fine-tuned LLM can be used as a baseline, but yeah, I think I saw a paper that was using the fine-tuned LLM and then used as a judge. But they said that it depends on the
Is it
what.
better in judging
I mean, in there, I can check it later, the which paper, but what I read is that in some tasks it was doing better, but some tasks it was not doing much better. Any other questions? Any other questions?